We all think we know what mental effort is. It is when we try hard, think a lot, or get tired from all that concentration. But in cognitive load theory, mental effort and cognitive load need to be more than a subjective comment, which is what this paper looked to explore. Because we don't yet have an accurate measure of mental effort, energy used, whatever that energy would be it in watts of electricity, blood required, neurons used, or any other metric, what these authors did was look at combining a subjective rating of mental effort with a performance measure to work out the relative efficiency of the effort. They define mental effort as the total amount of controlled cognitive processing in which a subject is engaged. In other words, how much thinking they are doing. What cognitive processing means is a different conversation, but for the purpose of this video, I'm going to use thinking. Performance is roughly defined as the effectiveness in accomplishing a particular task. It is often measured by speed, accuracy, or in the educational settings, test scores. The efficiency view suggests that a good score is when you put in little mental effort but get high performance scores. So if you don't think that much but do well on the test, you have a high efficiency score for that task. The experiment was 3 groups of people solving 24 problems. The control group being given the problems, but one experiment group was given training with partly worked out problem solutions, and the other group studied worked solutions. Each individual reported their mental effort on a 9-point scale, 1 being very low effort, 9 being very high effort. Unsurprisingly, those that had training got better results, which aligns with the cognitive load theory effect of worked examples, which I've covered previously. But the figure in this paper is where we start to see the efficiency being useful to educators. The conventional group at the bottom right was given examples to train with, but didn't have any completion on the examples. They said they put in lots of mental effort, but they got lower performance scores. This means the learning session or intervention was low efficiency for them. The worked example group got good performance scores, not quite putting in as much mental effort, so their efficiency was high. The same can be said for the completion group, but the performance scores were lower, putting in even less effort. A note I want to make here is that the problems, i.e. the performance tests, were in controlled environments. So the training of worked examples is likely to be more similar to the test questions. In the real world, there is likely to be differences, which could require problem solving. The completion group would have more experience with problem solving, so might actually perform better in everyday scenarios. So there is a balance to be made about the depth of understanding from the learner and the test being done. This is mimicked in their conclusion, with them saying the experimental conditions were more efficient for learning, but how you interpret those conditions is difficult. Going on to say that the efficiency measure should always be accompanied by an effectiveness measure, such as the percentage of correctly answered questions in the dataset. The authors also acknowledge motivation as a factor for performance, and the amount of effort being put into answering questions. What I find interesting is that they argue because the worked example group were given a test rather than a solution, they were more motivated to see how things would work when they were tested. That is their rationale for the higher mental effort from the group. To me, I see the logic, but I then wonder why the completion group had such a low mental effort. My suspicion is that preconceived notions and biased perceptions of effort impact the results, which is what we started with, an inaccuracy of mental effort. Although the authors say the efficiency measure provide helpful information about the instruction, I wonder how the results would fare if the essentially unhelped group was given assistance. Saying a group that isn't given help performs worse and tries harder, is less efficient, I think is quite obvious. What I'm looking for now, after reading this paper, is what happens when perceived mental effort levels and performance scores are compared between different instructional techniques. In this paper, there was worked out and partially completed examples. What about demonstration, direct instruction, or constructivistic approaches? And how can that be translated into lasting learning? I'm also not sure about the linear assumption between mental effort and performance scores. But what do you think?